Hello, I think I just went live. If you guys can get in the chat, tell me if my levels are okay. This is about how loud I'm going to be during the broadcast. I think I'm set up a little bit better with it today. I don't know. Still don't see anybody in the chat. Can you guys hear me? Oh, good. Somebody says it sounds great. Yeah, I realized that the levels were pretty low yesterday. And so when I got loud, it got really loud. So we don't want to do that. So I'm just pulling up a little bit of stuff right now. Getting my screen size set up. Doop. Okay. Actually, that doesn't need to be smaller. I think I just pulled. Everything's up to date. Okay. That looks good too. Let's test this. Excellent. A dev environment working, so it's about time to start the video here. Check the whoa, there is a bunch of people in here. 15 seconds lag. How do you guys know how much lag there is? Oh, because of the video to begin with. Okay, so let's start the video now. I say that because, well, actually I'll start in a second. I say that because what I'll do is I'll go back and edit it so the video actually starts at a specific time so you can get the intro. Anyway, now. So in a previous video, I was hacking these HTC Vive controllers and trying to figure out what the various messages that come from them are. Now, they're very well understood when you plug them in, but they're not that well understood if they're trying to communicate wirelessly. And one of the highlights from last time was that one of the developers of the Vive hopped in and started giving away some tips and tricks and stuff like that. Some of the things that I'm just assuming that the reason this is so much more complicated is because these things are using a Nordic semi-chip and space is precious. So he did a number of really, really clever things to try to pare down the amount of data that's being sent back. Unfortunately, it means that it's extremely difficult to figure out what he did. So in the previous video, we got a lot of stuff kind of torn apart and figured out. And if you haven't already watched that video, you probably should, or at least watch the starting of it because it kind of shows really what this is all about. And I don't want to go into that again. But what I did want to show you guys was so that AVR thing that I had working on here. Now it has 3 LEDs, and I can turn each one of them on and off individually. They are right now mapped into different holes on the Vive controller. So I can turn them on and off individually. And this is one where I have my environment ready, I have everything ready to go, but I want to make it more interactive. So what I'll be doing is I have the AVR code that I can easily change. And that's right here. This is all just the AVR code that can control lighting up a specific marker. And I can have code that'll do this, and I can have code that can light up 2 markers at once, or all 3 markers at once. And what we're going to try to do is we're going to try to light up combinations of these 3 markers to figure out what his code actually does, and what those funky commands mean. So I have no problem with opening up a gist on GitHub and copying and pasting a bunch of these examples into the gist so you guys can participate in real time. I'm honestly a little bit more burned out today than I was last time, so you guys, be great if some of you guys start to take initiative, start to really think critically about these packets and how they might be going together. So let's just start with first things first. Just so you guys understand what's in the stream here. Actually, first, Brendan, are you in chat?
I am, and I have it sticky, and I see my moderator rights are still intact.
Sweet. So for you guys who don't know, my roommate Inverse Phase over there, he is acting as moderator. He's actually working on a Python tracker, a Python like chiptunes music thing, and that's because he is a chiptune artist and he knows Python. So he's been out here the last couple of days up till 4 or 5 a.m. working on that tracker. Anyway, moving forward here. Let's actually get into what these different fields mean and a little bit about how we learned it. So what actually happens that comes back from the Watchmen, this thing right here, is the data comes back in 29-byte messages. Or up to 29-byte messages, and we're pretty sure that we figured out exactly how big of that message we care about, and just lop off the end. Additionally, we think, and this is based on some of the things that Ben had said, that the last 4 bytes, right here, the last 1, 2, 3, 4 bytes, are the CRC of the on-air checksum. So we can probably discard them, especially considering I think they would be the CRC of the encoded data. So I'm just going to ignore them for right now. Some of the other things that we found out is that it's bidirectionally encoded. So from the back of the stream going forward, you can look at the numbers and they mean different things. So the last 3 bytes here are the time code of when the thing happened. Then start reading back. This number right here is the length, in this case, of the pulse time. And then this is the code of which LED was the one that was on. So right now I'm only blinking 1 LED, so it's code 48. Let's just check chat. Yeah, we're in the DC Baltimore area. So it is US East time, and I'm not going to be able to stay up anywhere past midnight. Maybe, yeah, probably 12:15 is the latest I'm going to be able to stay up tonight, Eastern time. So that's about 3.5 hours from now, which I think 3.5 hours we should be able to get pretty far. 4 hours, Brendan says. So that's Inverse Phase in chat. I'm going to call him Brendan, but his stage name is Inverse Phase. And if you guys like chiptunes, I'm going to ask him to go paste a link to his YouTube. At any rate, moving on. Does anybody have any questions right now about the data as it stands, or should I just keep going into what we found out so far? Let's just see what some people think. I am expecting a little bit more feedback this time. How many people are in the chat?
Decent number. Seems like a dozen or so.
Okay. That's good that it's not as big, but okay. So what we know so far is the last 4 of the CRC, then the next 3 going from the back forward is the time code, and then comes this absolutely insane thing that Ben did. What happens is you're going backwards is you look at a number, and if the ones place, or sorry, there's a 1 in the 1/28th place, so it would be an 8 or higher out front, then what happens is you have to read the next byte over to find out what's really going on. So in this case, we have 0x0481, and so I'll just show you guys what that would really look like. So 0x81, 0x04. So that's a number, and so what we're going to be doing is we're going to be reading it from this going back. So the way when we would read this is we would first look at 0x04, and what that indicates is that there will be another byte because it's less than 128. And so we read the next byte. But first what we do is we shift it over 7 places. So 0x04, 7 equals I can't do that. That's a bummer. 4, 7 places. So that's 512, which is 0x200. Then what we do is we look at the next byte over, so 81. So because is greater than or equal to 128, it's a terminator. And so what that means is we can just OR it at the end and be done. So that's 0x200 or 0x81 equals 0x281. And that's the actual value. Based on some hints from Ben from last time, what we know is all of these values that are here, the values that will be after the start code, which by the way, the LED codes, 48 is the LED code. All of these back here are just relative times. So what happens is I'm going to pause this. We'll start at time A6, C5, D5, and then we know that LED number 48, notice they're all divisible by 8. He also pointed that out. So at any rate, point is, it starts at this time, this LED is on, and it is on for this length of time, which is decoded as 0x281, and then it turns off. And then that's the end of it. So right now, all that we're actually doing in here is we are turning on, or blinking at 2 megahertz about, a little bit slower than 2 megahertz. It seems to work better if I go like much slower. I'm thinking it's around 1.4 megahertz. I don't know why that works better. But anyway, I turn it on and off at 2.4 megahertz for a bit of time, and then I sleep. And so that's how we get this, the most basic code. This is really simple to read now that we know how to do it. It is a little bit confusing because the order of things is a little wacky. But it is totally. I won't brick the Vive again, Adam. It is totally doable. Oh, side story. I bricked the Vive yesterday, and it is bricked permanently, sort of. I was much earlier in the day. I was trying to read off the configuration data, but I accidentally had the set bit set instead of the get bit set, which actually made it wipe out all of the HID data for the configuration for the Vive. So I could still use like these things just fine. I could even read the headset, but all of the config data that talked about the gyros and the exact location of all of these things was totally blown away. Which also I found out that this is crazy with the, ew, it's all sweaty from me. Anyway, the location of all of these sensors is calibrated in the factory. So no two Vives are the same, and they know that, and the Vives store their config data. I blew away mine. Somebody on, I think it's Foxfire Dev, I think his name was really, really helpful. And he was able to give us a copy of his config for a similar Vive, which after tweaking some values, we were able to get going again. I can't really tell the tracking difference, but everybody online seems to think that this is horrible and that it's going to be terrible. I think I lucked out. In addition, Ben shot an email to HTC to see if they can actually pull a copy of our config from this Vive as it was shipped. Which if they do that, I will be so thankful, because then this can be restored back to 100%. And if not, well, it looks like I'm going to have to reverse engineer the rest of all of this mess so that I can go calibrate this myself. Oh. Really? So Adam, this is Adam is my roommate. He's the Vive, the other guy who has this, and he has it plugged into his computer. Yeah, by the way, if anybody does want to hack your Vives, definitely pull a full report from the Vive using Steam first, and use the Lighthouse tool in order to back up everything, which you can totally do. You can just dump the data. There's directions if you look up I blew away my HTC Vive config on Reddit, and there's a post there. Adam, I guess if you can, link it. Moving forward, I have the AVR, I have 3 LEDs, and I have my source code here. Just so you guys know, the tool I'm referring to in Steam is lighthouseconsole.exe, and there's a command you can just execute, and it works. Moving on. So the first thing I'm actually going to do here is I'm going to change the way the makefile works. And what I'm going to do is I'm going to say, if I say make test.hex, it's also going to burn. So if I just say make, oh wait, I want to say make. So now, if I haven't changed the code, it won't update the AVR. But if I change the code, so like, boop, saved, now it'll update the AVR. So what I can do is I can say while true do make sleep 1, or let's say 0.5 done. And so now it's going to be running that make over and over and over and over and over again. And so I'm just going to go move that off to another window so I don't have to worry about it. Now I'm going to go run the Vive data again. And what I can do is I can interactively, I'm going to be able to take the code here, and I'm going to be able to tweak it in real time. So I'm going to be able to say change this. So say I want to make it so the duration of the pulse is longer. Right now you see it's 0481. I'm going to say make it 40, whatever those units are. Now if you notice, it paused for a split second. That was when I saved the file. I'm going to change it back to 30. Pause, and it keeps going. Do you see how fast that is? That's instantaneous. And what's really going on is as soon as I save this file, it's going and it's reflashing. Here, I'll move this over to the other window here. As soon as I save the file, it goes and reflashes it, and that's it. AVRs are awesome for really fast development cycles, so that will totally work. Let's see what chat is doing. Okay, yeah, nothing really that clear. Yeah, sorry. Well, this is not going to be that long of the stream. This is going to be a much shorter stream because I'm going to have to go to bed by like 12:15 because I am beat. At any rate, moving forward, I can change this data right here, and I can load it into and I can load it up almost immediately. Oh, okay. So you guys are actually waiting and ready to get some data. Okay. 2:40 here. Oh, 2:40 a.m. Oh, that's a bummer. Let's get some data. Okay, so this is the most degenerate case. Let me see. Can I open up a GitHub? Sinlor or gist, right? That's how it is. No. Hub gist. Create a new gist. HTC Vive Watchmen hacking session. Codes. HTC Vive Watchmen codes. And let's start off with the AVR code. And what I'm going to actually do is I'm going to have some pound defines. 3 is 0, 4, 8. LED 40 and LED 50. Okay, so I have these mounted to the side of the controller, and we're only going to be operating on that one. So I'm just going to say LED 40, and we're going to just put this all together. So what I'm going to do here is I'm going to turn on LED 40, I'm going to wait a little bit. I'm going to turn on LED 50, and then I'm going to turn on LED 48. Okay, so that should be what we need to have done. I'm going to just delete that. Okay, and so I've just saved it, and it should be updating. Oh, it's not. Why is it not updating? Is there a compiler? There is. Oh. Pound to find. Oh, I have it backwards. Just so you guys know, _BV is a synonym. For one that. And it has to do with the way in which AVR GCC handles 16 bits. And it's still having a hard time. What is it doing? Oh, _delay _US. Oh. Okay, so now we have 3 LEDs that are turning on and off. 40, 50, and 48. Although it looks like I might have my order backwards, so that's a little concerning. Let's make sure that nothing really wacky is going on. I'm going to say 48, 50, and 40. 48, 50, 40. So now it's going the wrong direction. I must have messed up some code here. Let's check that out. Let me at least get back to something sensible, and then I will upload some dumps. HT survive. There it is. Yes, this one. Somewhere in here. I guess that was right. I thought it was wrong for some reason, but maybe I was just... $40, $40, $50, that's wrong. 40, no, that's really wrong. 40, 50, 48, is that correct? 40, 50, 40. Wait, what's going on? 40, 50, 48. Does anyone have any idea why these numbers are coming in the order they're coming in on? Because I would not expect this code to produce that output. Especially because I just tried swapping it, and I think I... $48, $50, $40. 48, 50, 40. So now it's right. Oh, you know what? I never rebuilt it. That's what the problem was. Okay, so now it's actually correct. So moving on now. So this is I guess a really basic dump, and I will go post this to just GitHub just right now. So the way this goes is I post my AVR code, then I post what the HTC Vive does. And so that AVR code there produces the following output. Kadunk. The output is post 0. I don't remember what the 16 is. Oh, number of bytes. IMU timecode MSBs. Then all raw light data. Then it goes events time colon LED code slash time code 1 time code 2 slash LED code 2, 3, 4. Notice the funky encoding of the numbers and the fact that parameters are read from the end of the data going forward. We know we're done when the number of parameters read is number of bytes left times 2. Bytes left times 2. No. Plus 1. Yeah, that sounds right. Is it? Let's see. Let's see, what is it? It is... note, all raw light data ends with 3 bytes LSB time code OTA CRC. Probably ignore. So let's see here. So we ignore the last 4, we ignore these. That's 1 parameter, 2 parameters, 3 parameters, 4 parameters, 5 parameters, and 3 values. So 5 is 3 times 2 minus 1? Yeah, that's actually right. Okay, because if you only have one LED on, you only need 1 parameter, because you only need to know the LED is turned on now, which we have because of the time code, which LED it was, and how long that LED was on. So this will totally do us. Okay, let's create a public gist.
Adam would like to know if you placed the digikey order.
I have not placed the digikey order. Which, by the way, digikey in me. So I'm going to link you guys this public gist. And actually, you know what I'm going to do is I'm going to stick it in the... actually... Brendan, do you have... Oh, I guess you don't have rights to edit it. Let me see if I can add that. Ah, I can. Do I save? Okay, people in chat, are you ready to start? Adam, email me the which LEDs you want to have added to the order. We probably shouldn't be doing business though in a live stream event. At any rate, I have now posted the first bunch of data. So this is a really simple case. I want you guys to kind of start looking at it and make sure you get a little bit more comfortable with the with what format this is in. And so I guess we're going to go on from there. Who all is actually participating? Who's going to be looking at this data and trying to reverse engineer this with me? You're probably going to be able to do it better than I can. Okay, good, Paul. So the first thing that I want to do, and this is something I don't know. Actually, George Allen, do you want me to just go over what the data means? If you can, have it pulled up in in just so okay in chat. Whoever wants me to go more into what the data means, just tell me, and I will try to go back and explain it more, and understand that I still don't know what certain codes mean. So I don't know right now, and I'm going to try different things to create those codes, and we'll see if we can figure out what they mean. Nobody's saying anything. Okay, that's fine. I guess I will just start engineering. The first thing I wanted to look at was if I turn on 48, and at the same time as 48 being on, I turn on 50. So I can say or LED 48, and then I turn off LED 50. So back to LED 48 only. Yeah, I know, it is weird. How crazy is that, man? Ben just like must have engineered this thing to be as tight as possible. It's just awesome. I mean, okay, not really awesome, because if he didn't engineer it to be as tight as possible, we'd be done and I could move on to something else. By the way, actually, was that too loud, or did I get the levels right? I hope I got the levels right. Okay, I will add the note about parameter fields are encoded. Read from end going forward if value in, or if MSB is
Just in case you need some.
oh is 1, i.e. 0x80, it is done. If not, then need to read next byte. I'll copy and paste the explanation from here.
This stream brought to you by caffeine.
No, not me. I actually have to sleep. I actually did not sleep at all Saturday night because I was too wired, so no caffeine for me. Any rate, so I'm going to go update public gist now. Okay, so if you have the gist open, refresh your page, and it will be updated for you. So the next thing that I'm going to do now is we're going to look at the data if I do the whole thing. So if I turn on LED for LED 50, ooh, you know what I should document is length of time for following. So anybody who's just tuning in now, what I have is I have the AVR taped to the Watchmen controller with 3 LEDs, and I have my AVR code here, and I can just save it and it reflashes it immediately. So if I'm running this, if I change the code, so if I comment out this block right here and I say save, it pauses and then it keeps going. So what I just posted was a really basic thing. Maybe I'll post this as another example just to see how simple it can really get. Okay. Then the more advanced one, the one I wanted to show you guys that I don't understand right now, is this one. So what we're doing is we're turning LED 48 on, 50 and 48, and then 48. So I'm going to save that, and why did it not like that? Oh, herpaderpin. Okay, saved it, and now it's updating. So now, this is a little bit more complicated. it turns on for a little bit, and then turns LED on just for a little, LED 50 on for a little bit, and then back off to just 48. And it produces a code that makes no sense to me. So I'm going to go upload that here. So that produces that. And then what I'm going to try also is swapping it around. So it'll be 50, 48 and 50, 50. So we're going to see what that looks like. Notice how they are different, so do not understand what's going on here. So one of the things Ben told us last time was to take note that these LED codes were all divisible by 8. And so what that means is there's now 3 bits left over at the beginning of the LED code to tell us additional information. I don't know what those bits do.
This Elful is asking about your workflow, and I mentioned that you're probably just up and entering on a make and run this command line and Control-S-ing in the text editor.
Yes. So I guess I should say that again. Again with the environment, what I've done is I have it set up over here with make in a loop. So what's going on is the system is constantly looking for new changes, anything it changes, and if it changes, then it will recompile and send the new binary to the AVR, which is hooked up to the Watchmen. So if I just save the hex file, recompiles it, reflashes, and now this AVR is burning new code. I wish I could have this hanging here so you could see it, but I don't think it really matters. So now if I run this, and by the way, what I'm going to do right now is I'm going to save the gist. Okay, this is going to live over there now. Or not. Apparently, how about that? There it can live. Yes. So, does this give anybody else any ideas for things that you want to start looking at right now? I think some of the things that really stand... Oh, this is not going to be good. Okay, there we go. Some of the things that stand out to me is you see the 48 and then you see the 52, but the 52 has the 1 set in the 2's place, and the same thing is 4A. So over here, if you look, when it goes one way, it's 54A, and then here it's 4852. And so 4A is actually just 48 hex. With the 2-bit set, 48 hex with the 2-bit set. So something about what we've done here makes the 2-bit get set. One of the things I want to check next is to make sure that these times are doing what we think we're doing. So I'm going to set it, so instead of being 40 microseconds each, I'm going to set it to 80. Actually, I guess I'll keep the first one at 40, then I'll make the 80, and then I'll make it 120, and we'll see what happens. That's not what I would have expected. That number does not look like a legitimate number. That number looks much, much larger than a legitimate number. Maybe something is wrong in my code that would identify that. 40, 80, 120, 140. 1980. Okay, so it is still working. As I make this number bigger, it makes that value on screen, this number right here, the length appropriately larger. Oh, that's weird. Apparently there's a maximum you can get to. I think. Oh, that's weird. It like wraps around. Uh-oh. Oh, I'm confused now. Let's start small. Okay, so I don't want to actually do all 3 LEDs at once, because I can't control which or when it starts detecting them. You'll get like conditions where like it'll turn on now and then this one will turn on, but I don't know which one really turned on before the other. Is marker 8 bits? Yeah, I don't know what's going on right now. Why do you guys want to look at the streams? Can you guys read the numbers on my screen clearly? So the 50, the 5017 whatever. I don't know why this is. So 10 microseconds, 183. 20 microseconds, 356. 40. Okay, this is working. 80. 90. 100. Oops. 100. 200. 300. No, 300 broken. 220. 240. 230. 240. 250. 260. Thank you. Thank you. I got that. Now I feel dumb. Thank you. Okay, how are we going to do that then? Okay, then just to make sure that this isn't going to completely get hosed, I'm going to have to put a loop around the outside. $255. Okay, we're cooking again. Charles is not all dumb. George Allen says it's inconsistent. That seems pretty consistent to me. If I take twice as long here, it goes from 4470 something to 98 something. So I'm pretty happy with that. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12, 13, 12. Okay. We're going to have to remember this for later because I think this might be important. I'm going to make a note of this in the gist, that produces this, but 13 produces nothing at all. So that would mean to me that maybe what's going on there is that maybe this value's maximum is 6553, well, you know, around 65,000, which is interesting because that means that maybe there's a way to encode more data above that. Because there's definitely data available, because like look, it's 037BB7 is 64951, so there's room for more information to be there. And let's see what that actually works out to. Let's see if that's reasonable. So calc, so 65535 divided by 48 millionths of a second. Oh, that's 5535 by 48 millionths of a second. That's 1.365 milliseconds. Let me go look up the... where's the light? Oh, here it is. Somebody had documented what the light emissions were. So that would be TIX 2000. Okay, so this system should never ever be running into an LED receiving data for 65,000. So let's just take a note that mental note that the numbers could be over that. So the reason I don't think 65,000 is the maximum, or I think it is the maximum, the reason I think that there might be more data there that we're just not seeing is because it's 65,000, the representation is 0, 3, 7, whatever, and then another number. So that leaves plenty of bits of space left. And knowing Ben, there's no way he's going to be wasting those bits.
Just watch, he'll chime in.
I mean, as far as I know, Ben's not watching right now, so we can make fun of him, right?
I think you might get a surprise.
What do you mean?
I said, I think you might get a surprise.
Oh, is he actually in?
I saw a comment earlier, I thought.
Okay. Never mind. Maybe Ben is watching. So let's go do this. Okay, so that's interesting. Let's go back and keep doing the test from where we were. So this one is 50, 50 and 48 and 50. And I'm going to make this 80, 90, 100. Are you guys seeing what I'm seeing? Because this value here is definitely not 0. Or not between the two numbers. I'm going to add that to the gist. Okay, so there's interesting data. So 50 and 48, but this bit here is high. Means that somehow between these two things is encoded the information necessary to understand that it can be turned on and then something and then off. Let's just take that and okay. I don't know what to do with that. That's very strange to me. Let's go back to 80, 80, and 80. 80, 70, 60? Oh, weird. Okay. This data is definitely doing something that I would not expect. What? Okay, so it looks like the major values are the same, but the minor are not. Does anyone mind poking at the... Here, let me gist this right now. So hard to get it. Does anyone mind trying to figure out what's going on there and why my code is, when that particular number gets large enough that that could be wrong? If somebody doesn't mind like reverse engineering that string there, and making sure that I'm decoding it at least as far as we think correctly for that there. This is just plain because this is what I would expect, this code down here, because if we do for 30, 20, 10, we see the lengths of time go from 543 to 324 to 185, which, like, to me that makes sense. Like 185 times 3, you know, 540-ish, you know, whatever. But what doesn't make sense is why I'm doing the same operation, LED 50, 48, and 50, and 50, and that's going on there. I'm going to go back to chat now. Are you able to edit and put it? What are they asking?
I think he wants a link to the GitHub project or something.
Oh, link to the GitHub project? Okay, I'll add that. I'm adding the link to the GitHub project in the description. I've already added a link to the gist in the description.
I don't think I can edit the video title because
no, I don't think you can either. It is very good that an AVR has got more than 10,000 write cycles. Hello. Hi. Is this the George that works with Kevin? Anyway, moving on. So if you guys don't mind, if somebody can just double check that for me, the gist, and try to figure out why. Oh wait, somebody's commenting. Oh no, what does this say? This produces 48 for the LED. Okay, Mobius Horizons, what is your name in chat? Who are you? Let's see, I think I saw your icon somewhere.
Identify yourself, soldier.
Yeah. Oh no, what's going on? Okay. Yeah, it just does look funny. Oh, hi Paul. Okay. Okay. Let's see, what should we be changing next? Part of me really wants to understand about that time. So maybe... Oh, that's just so weird. I don't know why that's the case. Last bit set LED 50, but shows no data, something else. I don't know. How about this? Let's just try turning on different LEDs. So 40, 40, 40, so it'll be 48 and 40. Okay. I'm simultaneously, how do I explain that? No, I'm right now, we're operating only with 2 LEDs, and we're already getting data that makes no sense to me. That we're definitely going to have to figure out first before we start getting into the third LED. Okay, so maybe the different LED will give you a little bit of data there. So that's LED 40 and LED 48 and LED 40, and it produces 48, 42. I guess I could do it the other way around. 48, 48, 48, 40. Why does that not work? No. It's because the vive thing moved a little bit. Splendid. Now it's a much more concise syntax for gist. Back to the chat. Okay, so can you guys think of any new tests you want to run right now? Let me know. Anything else we can think of? Something that's like nice and simple. Something just to try to figure out. Maybe, I mean, I don't even know what else we would be able to figure out here. 50 and 40. Maybe if we, oh, I know what we can do. We can turn on 40 at the same time as 48, and then turn off LED 48, but leave 40 on, and then turn it both off. So let's try that. That's a little bit of a different thing there. That's instead of being 44, something going on here? Oh, whoops, there's bugs. Let me go fix the bugs first. Yay! Okay. Okay, now we can see that the code is different. Okay, so now we think we got that working. On non-overlapping pulses. Okay, Jeremy, I will do that for you. So LED, which LED should we do? Just LED, say 48 and then 40? like that. 50 US, pulse 30, pulse 70. Done. Let's see what that produces. Okay. Okay, what else? Any other ideas next? Swap LEDs. Which LEDs? Do you want me to do the test that we did a few minutes ago, like this, but with just different LEDs? So let's say 50 and 50. That would be that. I guess I can do another one yet. Let's do 40 and 50 at the same time. Okay. Come on, guys. Need some more ideas here. Anything you guys want to see? Daniel, you had some suggestions. Variable length quantity on Wikipedia is good for explaining some concepts. Brendan, can you check that and see if I should add that as a link to the gist?
You mean you want the link?
No, I just want you to check Wikipedia and see if it's worth adding to the gist.
I mean, I think so. Universal code that uses an arbitrary number of binary octets to represent
Okay, guys.
a fairly large integer.
Okay, yeah. Can you put the link in this thing and I can paste it in?
I will post the exact link.
2020. So the time code is a big issue. Okay, I can do 2020 and 30 or 2020. Let's see what that looks like. That's 2020. Let's make sure it actually is. I'm going to save it. Yep. Now, as a big note, because this is an analog system in here, 2020, depending on the order in which things happen, the 20 is going to be different because it's going to have a different analog value as it goes. So I will record that, though, for you. Twenty-one. And I guess I'll just do 22 so we can make sure that it is behaving the way we think. Okay. Any other ideas from anybody? I guess I will add this to the I mean, we've already tried a bunch of different timings. They're available in the document here. The AVR code is sitting in the GitHub repository under the tools folder. It's already there. Oh, you mean commit? I guess I should. Okay. Ding. Anything else you guys want to see? Oh. So based on some of the hints, like deltas, or whatever Ben said, we think that all of these times are the time are the deltas between the start time. So it would go start time, delta, or start time, whatever happens at the start time, like a pin transitions. Then the amount of time before the next event happens, in this case the pin going low, or this other thing turning on. So they're all written as deltas. And so yeah, that would be, it is probably about 60. Understand that there's definitely going to be like DC offsets in that length of time. So it's going to be like offset by a certain amount. So if I turn it on for like 3 frames, it's probably not even going to register at all. Whereas if I turn it on for many more, then there's going to be the nonlinear drop in the beginning. If you suggest some other time codes, I can certainly try it. I guess I'll try 5, 5, 5 and see if it reads at all. Whoopsies. Yeah, it's not even reading barely at 5. So if I did 8, 8, 8, that might read. Yeah, that read. Although that did not read the way I would have expected. That's interesting. I don't have a UART connection, but I do have a tiny ISP term connection. That's an interesting idea. But it would be difficult to like re-correlate the data. Well, I mean, let's just see. Maybe I can do that. I know I have a copy that I wrote somewhere. Sure, let's see if this has Tiny85. Aha! There is a copy. We can just use this. and came from here. I'm going to include AVR print, if I can remember how. I think that's it. And it's setup SPI. And then we're going to do, let's just yes! Okay, we can actually get data coming back from the AVR. So you guys wanted me to do a sweep or something? I don't know how I would correlate the data though. Oh wait, so people are saying other things. Well, now I can, oh yeah, no, nobody was able to decompile the firmware. We didn't find any good thing for that. Actually, if any of you guys can go find a good decompiler for 8051 code, that'd be awesome. But from what I could tell, nobody has a decompiler for 8051 that's any good. CN Lore, can you check LEDs 40 and 60 on uniform timing? I cannot test LED 60. It is not hooked up to my controller. And I don't know. My butt doesn't fall asleep. So 30, 30, 30. So yeah, I don't know what you want for... No, he totally said this was an 8051, one of the, not Cypress chips, one of the Nordic chips that has a 8051 core and Wi-Fi. Not Wi-Fi, wireless. It's a really draconian interface. I've used the NRFs for a while. Ha! That totally works. Or does it? No, something's wrong. Why is code broken? Code broke. Code broke, not good. Oh, you know what? If I do this, I can only access LEDs 48 and 40. LED 50 is wired up to the SPI bus for printing, so I'm gonna not do that right now. Okay, everything's back to normal.
Paul just wants LEDs further away from each other.
Paul, how much do you want the LEDs further away from each other? Because it does mean pulling all the tape off. VK2Zay, if you don't mind, please pull the firmware. Apparently they say it's unencrypted, and go decompile the ARM firmware. That would be super swanky. Tell you what, Paul, I will do you a huge favor here. I will pull this thing off and put it on another side.
Could it be that the LED number is only the bit field of which receiver is receiving the signal? Asks Fritz the cat.
I do not know what he is asking. That's interesting. Oh, okay. Yeah, I don't know how to get this set up in such a way that we can test this easily. If we can, let's just do that later. This
Daniel
is
Wee asks LED 50, pipe LED 40, probably an OR operator.
yeah, that would be an OR operator in this context.
Does the info change if you try LED 50, then LED 50 or LED 40, then LED 40? Is his suggestion.
Okay, so he wants to see. Oops. If you try 50, then 50, then 40, then 40. Okay. 50, then 50, then 40, then 40. Yes, it does change, actually. That's really interesting. It changes to exactly the opposite.
Kai asks what Watchmen is a nickname for the controllers.
The Watchmen is a nickname for the the wireless controllers. Okay. Do you have any other recommendations for things we can look at right now without having to try to reconfigure the physical configuration?
While you're waiting for an answer on that, OTT wants to know if there's a way that you can get summarize what you figured out in the last 3 hours of the first stream.
I guess we've been recording for a little while now. How long has it been? It's been an hour and 20 minutes. Okay, I guess it is time to summarize the previous stream. So goal for the previous stream, figure out what these guys did and what the wireless communication was, because the unwired communication is very well documented. No, wired documentation is documented well. after we found out what the basics was, the trigger and all that I did on my own, then we started to try to decode the light data. Amazingly, Ben, one of the guys who designed these things, hopped into chat and started giving us little tips and tricks and everything. And then after a little while, he started giving us more and more information. And we were able to find out a number of things. One is they're variable length fields. Two is the parameters are read from the back going forwards, and then the actual LEDs are read from the front going back. And the number of bits inside of everything, the point is it uses variable length fields. And then we found out that the last 4 bytes were probably the OTA CRC, which means we can ignore them. The next 3 bytes are probably the timecode byte, and then all of the parameters are probably deltas between different events. And I'm definitely seeing the deltas between different events as a thing that I'm pretty sure that's actually what the case is. So Paul says 10, 20, 30 on 40, 40, 48, 40. So 10, 20, 30 on 40, 48, 40, and 40. I guess that's it. I know you guys probably want to keep watching that shrink down, so I'm going to be up here. Okay, so this is what Paul has requested. Yeah, you're going to lose the stream right after this, so... Oh my gosh, it's so tiny. Let's see here. So I guess what I would do is copy that here into... Yeah, sorry guys, that inception thing is totally done now.
10, 20, 10. Yeah.
I hope you're not just messing with me, Paul. I hope you're actually thinking critically about this. Yeah, it looks like that just changes the last number here, which is what I would expect. Oh, hi George. We haven't talked in a long time. That's another side note. We already are decoding all of the button data, and I'm handling that separately. And I'm pretty sure I'm doing it right, and I'm handling all the IMU data. I'm pretty sure I'm doing that right. So I should be able to click the... That's the wrong controller. I should be able to click the buttons all I want, and it should have little or no effect on the what actually gets triggered. So maybe there is 1 or 2 unknown things, but as... Like I can see that sometimes it's flashing, but as later on we'll figure out what those do. Some flags turn on, so he's... Okay, do you have any more tests that you'd want to do, Paul, on the... Whoa, okay, hi Daniel. The timings for 44, 50, 54 is different. Would have expected... Okay, so there's something really important going on here. The LEDs can't be mounted perfectly with the... perfectly onto the dots. I've gotten them pretty good, so don't expect the numbers to be like spot on when I change something, unless we exaggerate the values a lot more. The first static bytes, i.e. not messing with you. First static bytes. What are you referring to? Okay, so originally I did this by having the lighthouses on because I figured how hard could reading this data be? And I had the lighthouses on and I did a bunch of dumps and nothing made any sense at all. So we switched to using an AVR to send out the pulses to the controller because that would have made it, now I can actually control it and we can see known pulses about what it is and actually look at the outputs from that. So there was somebody else who mentioned something. If you actually have another test you'd like me to run, I'd really like to hear it. So Daniel Wee, if you have anything else you can think of, that would be really cool. Otherwise, if you guys want, we can move into 3 LEDs now, just to give it a shot. I mean, I guess I could just do a few more tests on this. Like, I'll make this 20, 10, 40, 40. Or actually, let's do 10, 40, 80. Exaggerated a whole bunch. To me, that looks perfectly normal. I'm trying to figure out the meaning of the LSB flags. Yes, the LSB flags matter a whole bunch, and I don't know what they mean. It would be super cool to find out what they mean. $40, $44, $40, $50, and $40, and $50. Okay, let's do that one again. $40, $50, and $40, and $50. By the way, disclaimer, I am like not a pro at this, so there are people who are much better than me, but I figured it was fun to try to do this kind of as a community thing. So if you guys like it, we'll just keep on going. And then I guess we could flip around the other way. That is interesting that the ones place indicates that the bit that's on changed or something like that. For the next little bit, actually, the ESP8266 doesn't have any more planned projects on my radar, so I don't... Well, actually, there is one big one that's going to be coming out, but it won't be a stream. It'll be a straight-up video. This project that I'm doing with the Vive is specifically related to ESP32 project that, if everything goes well and we can get everything that I want hacked, we'll be able to do it. No, I think that was with 50. And no, it's not 8266 Vive combo, it's 32 Vive combo. Maybe, if we can get this all figured out. Daniel, can you tell me some more tests you'd want to run? By the way, in the future, if you guys can use the formatting like 40 or comma 50 or 40 comma 40, that'll make it a lot easier for me to type the code to test what you want to test. Oh, spectacular idea, T King Fist First Cat, or however you pronounce it. I'm going to make it 40, 40, 40, and we'll do it 3 times. Whoa. That's really interesting. That's a really interesting idea. I like T King First's idea here. Let's go with it. Let's do it one less and see what that does. Oh wow, it even does it that way different. Oh guys, look! Oh my gosh, the number it's big. It's a big number. It's
27 byte limit is a limitation of the hardware, right?
20, yes, cannot be more. There's a hardware limitation where the messages cannot be over 29 bytes long, and it does have to do with the hardware, or 27 because there's the partial header. So there's that. And then this one also has a really big number, which is super interesting. Okay, that was a really cool test, Peking Cat. Do you have any other ideas? I'm totally up for hearing it. Daniel Wee, 40, 48... Wait, what?
48, 48, or 50, 50.
Okay, I guess I'll do that. 48, 48, 48, or 50, 50. How many people are in the stream?
I don't have that part open.
Okay.
It looks like... Oh, I can see active usernames.
You know, I don't actually know what would happen if you exceeded the limit somehow.
There you go. 56 active, 57 viewers.
Okay, got it.
13 active in chat.
Okay, I hear more people out there. If you have any ideas, come on, chime in. This is we're definitely yeah, that is weird. What is up with that? You know what? Let's just do a sanity check. Let's just make sure that the LEDs are still mapped correctly. LED 48, LED 40, LED 50. Okay, so the LEDs are still mapped, thank goodness. Tell you what, let's purposefully go over the limit and see what happens.
Fritz asks if you can position your windows so that they can see the real-time data while they're thinking.
Oh, this is...
Even just like the bottom 2 lines or so.
Say what?
Even just the bottom 2 lines or so
of what?
Data flying in.
Oh, I tried doing that, okay. That's weird. If I do this, it freaks it out and it won't tell me anything. So...
The controller firmware is in the SteamVR decode, right?
I don't know. Huh. Well, apparently, if I try to go over something that would take too many bytes in a short period of time, it just freaks out and stops. So, don't know what to make of that.
But the only thing we know of is the SteamVR decode, so I'll let it know.
That is interesting that seems to break it. I don't know why. Oh yeah, sure, let's do that. Let's also undo so we go back to the interesting thing. That one. That is super interesting. There is something about that second number that is absolute magic. Tell you what I'm going to do. I'm going to change this to 48, 48 or 50, 48, 48 or 50, 48, 48 or 50, 48. What are our people saying?
Trip suspects that pushing it over via delay is different than pulse number. Daniel Lee is telling Paul about some of the stuff. A few people experience a video freeze but say it's back. And Admaled was asking about the controller somewhere, but doesn't know where to look other than the Steam VR repo.
I wish I could remember where Mindy said, or Adam found that last time. I don't know if Adam's still on the channel. He could tell you where to get it. Okay. Do I need to restart my session? Let's see what the lag is like.
Now it looks like people just weren't clicking live because you can click live to full
No,
screen.
my session is actually behind.
Are you talking about the YouTube video?
Yeah, like.
Click live in the window.
Oh, I should click it?
Click on live and it will sync you to the like it'll drop your buffer, basically.
I just clicked it, but it didn't seem to do anything. Wait, should I do it?
Well, I mean, it doesn't matter if you do it.
If you guys can, like, somebody who has resunk the timing, see if it's back to fast.
Someone was like, or change speed to 1.25. You received a ping. You're doing fine. Your lag's okay.
Any other ideas that you guys have? Ping. Oh, ping! I just finished entering. Ping. I see ping right now. Okay. Anyway.
Yeah, 9 seconds is normal.
Yeah, okay. That's good. Okay, guys, this is good. What else should we be taking a look at? And by the way, I'm not sure if this is going to change because my guess is that somebody like bet Ben that he couldn't get all this data down to a certain size, and I think he did, because this is doing some stupid, crazy things to get this data as small as it is. So Daniel and, oh gosh, I've already forgotten your name. You've been so helpful. Paul, if you guys have any other ideas for tests we can run, I'd really like to hear them.
Daniel suggests looking at the bits flags. Paul asks how that works with the timings. There's a time for 3 LEDs from Paul. Or increase the delay.
I think it is time for 3 LEDs. Let's do 48, 40, 50, 48, 48, 40. Oh, I just got myself confused. Oh, whoops. These belong here.
See?
So if you guys didn't just notice, I just changed the, so 48, 40, then 50, 48, then 48, 40, or sorry, 48, 40, 50, 48, 48, 40. And that's what this data right here is. That is interesting that it goes 48, 40, 50, 40. Oh, that is interesting. That maybe there's something going on where 48's code is saying, like, I will be on for this long, while 40 is on for this long, and then this long, and this long, and then that long. That is, because that would make sense, because 48 is going to be on for about 4,800, 48 millionths of a second. So Paul, what is your recommendation for code? By the way, we want to get a lot of tests in because you guys can check this out and read it tomorrow. I'm only going to be doing this tonight. I have work to do tomorrow night. Okay, we can try that. So, delay US 10. Oh. Oh, I see. Okay, so I'm going to have to... oh, that's interesting, though. Oh, no, never mind. That's dumb. Physics dude, it takes about what is it? It's 120 hertz per fast one, so it's divided by 4 is 30 hertz to sweep a room. So it'd be 1, 2, 3, 4, and that operation happens at 30 hertz, I think, or no, 15 hertz. Yeah, about 15 hertz. Daniel Wee, can you specify what you're actually asking for? Like, whenever you guys want me to try anything, be as specific as possible about what you'd like, what AVR code you'd like me to change. It's not 60 hertz. It's close, but it's not 60 hertz. It's not 16.66 milliseconds. I'd have to drop the stream to go back and get... what I did is I took photodiodes and I collected actual data from the lighthouses and loaded it up in a logic analyzer. So... gosh, come on, there's got to be something else we can try. Maybe I'll turn on several LEDs. So let's try that, then 48, 40, LED 50, then that, then that. Oh, what in the world? How? What? What? No, surely... Oh, there we go. Yeah, that's a little more like it. Any other suggestions? Oh, you think he was on the project, so he's saying it should be 60 hertz or something. That's funny, because I just remember when I was looking at it, it was way off, I thought. Part of me wants to go get that file. It might drop the stream, but I'm going to try to get it. Did it drop the stream?
Well, I'm not looking at the live one.
Please look at the live.
Yeah,
What does it say?
waiting. Still says it's live.
Let's see. So you guys didn't see my password come up, did you?
Here. Live feed is black screen plus cursor. Now it's back. Yeah.
So just so you guys know, what I've done here is I used two photodiodes. Channel C was, this one right here was on my lighthouse that said the letter C, and this one here was on the lighthouse that said D. One of the things that kind of surprised me was that both lighthouses actually send out a pulse every time, whether or not they send the sweep. So lighthouse 1 sends out pulse code sweep, then the other lighthouse sends out pulse code sweep, pulse code sweep. So the one guy said this was 60 hertz. Oh, wow, I was completely wrong. That is almost exactly 60 hertz. I have totally made a fool out of myself. Let's look for the beginning slice. Ha! Okay, it's exactly 60 hertz. I don't know what I was looking at before that made me think it wasn't. So I don't know, whoever that was, who was it that said 60 hertz?
I don't remember. Oh well. Your apology is accepted, I'm sure.
Yeah, it is. It's pretty accurate. I guess when I first looked at it, I must have just been looking at different things that I don't know what I was looking at. But as you can see right here, it says 16.66 or 65. It's 16.66666 milliseconds. You're dead on. It is spot on. So I guess I can close that now. It's chewing up all my CPU. Okay, so what else can we test? 48, 40, 50 there. I don't even understand how it would be even remotely possible to represent all of this data with this few bits. That's just terrifying. It's just completely terrifying. I don't know what Black Magic Ben did, but what? Also, side note about the Sele, I don't own a high-speed Sele device. I only own 2 of the cheap Chinese knockoffs. I have access to a high-speed one, and the only reason I have access to it is because I had the cheap Chinese knockoffs. So if Sele had actually done something to stop people from using the cheap Chinese knockoffs, they would not have made the sale. So they're all up in arms about people using knockoff Seles, and I'm going to say that they really are going to have to stop that if they expect to keep on selling their expensive ones. I guess I can just try a different code, like maybe 40, 48, 40. This is very strange. Come on, go down. Oh man, I gotta reload the chat window. It's all janky. Oh, that was better. Okay. Okay, well, I mean, is there anything else you guys can think for me to test right now? So, like, we're doing 48, 4850s. Oh, hey, side note, did you guys notice that that huge number just now jumped to 42 instead of 48? Man, I don't even know what to try anymore. This is so crazy. Okay, whatever. Let's just try the third thing and see what it does. That's interesting. So that one right here, it's as though it's a continuation of data somehow. I don't understand how it can represent that or how we would know for sure. Unless the time codes line up just right. Oh. Okay, well that's neat. Okay, well, we got to get some ideas here. What else can we test? I guess I could do this and then change this to... By the way, I'm thinking part of the reason I couldn't sleep Saturday night was because I was thinking about this and what all of these different fields mean. So it's totally killing me. Like, just out of the aspect of it being a puzzle, I want to know what this data means.
Pretty much everyone agrees with you.
Let's see what this does. Hey, a 1-bit just got set. Did you guys see it? Oh my gosh. Hold on, I'm gonna paste this into the this thing. Oh, that's so weird. 4B51. So it's like the 1s and 2s bits have to do with it handing off while the other one is on. When the bits aren't set, it's something else is going on. So that all goes back to the previous one where 4 will not. I don't think 4 will read, but we can try it. 4 is barely reading. 6 should read. No, it's still not quite reading. 8. Ah, 8 reads. Let's be safe and make it 10.
summarization.
I don't know, man. Let's go back to a more degenerate, or a simpler case. Back when times were simpler. So I want to just do this. 40, 48, 40, 48, 50. One other note, if you look up here, you can see what happens when the pulse codes leach over into the next frame. I don't think we're losing anything in the packet limit because there was that one packet back a couple where it just went down to the next packet. Here, I'll show you. So here, check this out. What's going on is it's going down to the next packet. What do you mean, what does it look like on actual Watchmen data? Oh, you know what? I don't even have any way of collecting the raw HID data coming from a wired Watchmen. I haven't written that. I never did. Never thought I'd use it. It'd be too hard to get right now. How about we just make more events and see what happens? Or 48, 50, 48, 50, 48. Oh, that's really clever. Oh, okay, so what they're doing, if it would be something that would bridge packets, they just separate it out into its own packet and then treat it as a separate piece of data. And then they just set the time code such that it would be beforehand. So like right here, this is actually just treating it as separate 4850, 4850, 4850, 48. And then this one here is saying 40 was on from here until, you know, whatever the packet end was. So, oops, I copied the wrong line. Or I guess that would be the opposite. What really happened is it was this one. No, 46. Oh. Yes. Okay. So if you look at this packet right here, the time code started before this packet. So the system was smart enough to know to take the 40, because it was common to all of these, and then go stick it after this packet, even though the event started in this packet before this packet began. So the things, I guess, don't have to come in order. It just, I guess it's really clever about the way it just stores them and sends them onward. So maybe this isn't going to be as hard, because maybe it does a lot of the really hard work. I understand VK2Z, but I don't have I just don't have any way of decoding it right now. Oh, hey, Ben's in here. Hi, Ben. And Ben, if the factory has it, it'd be really cool. Oh yeah, let me go commit the current gist. Ben, I think you can see just how many people are really excited to figure out what this is. The one thing that I want to say is I cannot fathom what it took in order to write something that could look at the light pulses and figure out how to put these crazy things together. So guys, do you have any other ideas for different tests I can run right now? Maybe this one right here.
Oh dear.
What?
I made an oops, and I realized what I did.
Ooh, the 4s bit is set here.
I drew a font, and I was like, why isn't the font showing up? And the answer is the font is showing up. It's just the wrong part of the font. Things. There goes things. Save that file. And then suddenly my thing.
Check that out, guys. The 4-bit is set in that one. I can't believe this. Maybe the 4s bit. Oh my gosh. Wait, are you guys already talking about this? The 4-bit might be the bits that turn off when the 49 is 48. No, that's 48 and 1. Oh, 50 is 50 and 1. Never mind. Well, then 44. Oh. Tell you what, let me change the numbers of the timing sum so I can make sure that I'm seeing what I'm seeing. Yeah, no, I'm still lost. Although, hey, this does prove that it's deltas. I mean, despite the fact Ben told us, but this does actually show that it has to be deltas. So all I'm saying is, like, look at the 4-bit here, and the fact that it affected something that was all the way 2 back. Whereas the 1-bit, I think it only affects 1 back. The only thing I don't understand is the 48 turning into 49. I would have expected to see 49, 52, 44. And that would have meant that it was looking 2 back instead of further back. I don't know how to... It's hard to put that into words. Ben, in chat, can you tell us what it's like to have a bunch of people trying to solve a problem that you already know the solution to? Not just the solution, it's like a puzzle, and you know exactly what the puzzle looks like and where all the pieces go, and to watch all of these people try to figure it out. Oh, that's a good point. I really should tweet this out. I guess there's no information on my Twitter that you guys can't. Actually, you know what? I don't have the URL for this live feed. Can somebody paste the live?
Tweet out CNLR, YouTube/CNLR/live.
Oh, okay. Is that it? It's just YouTube CNLore
.com. Yeah,
slash CNLore. Oh, it's /C/CNLore/live. What?
both work.
Slash.
Does that work? Why am I getting B's?
Oh, are you serious? VK2Z. I think it's worth. So Ben says it's pretty entertaining to watch a bunch of people all. What's the LVQ or LVLQ? Oh. Okay. Back to work. Okay, so let's see here. What would I change next to try to tweak that bit? Oh, hey, 6. We got a 6 again. We got a 6 again. Let's take a look at that. Put LED 50 on for the whole time? Okay, I can do that. Oh, Micah. That's sad. Micah, can you at least tell us what the toy was, or are you under NDA to tell us what it is? Oh, so you want 50 on. Okay, so 50. I'm going to make this 40.
Second gen CPU cubes.
Say what?
Mike answered you. second gen Scipio cubes.
So if you are interested in seeing the 6, oh, I guess that's the 6. So this is, oh, I done goofed something. No, this is it. This is the right one. 49, 42, 50 is LED 50 is on the whole time. That is very strange. Why, when I move LED 50 to being on the whole time, it's still showing a 49 in the beginning? So how does it, what is it doing?
You've been asked for a brief description of your hardware-software setup.
What is Siftio? I've never heard of this. Sorry, I'm right now just looking up something that one of the guys in chat helped program. Siftio cubes. I've never seen these. This looks pretty... Was it like for a game, I guess? Huh. It's pretty neat that they got the little displays, and he said, I guess they're wireless. Hey, Siftio, is that... I think somebody did hack your stuff, so I would say you should feel pretty special, Micah. Sorry, yeah, Micah. It looks like your stuff was hacked. Anyway, back to work. We got to get back to work. Sorry, what did you say, Brendan?
Explain to George your hardware and software setup.
Okay, it's time to show. Say what?
He said very briefly. You can describe.
Okay, very briefly, hardware and software setup. I have a Watchmen controller here that I have taped on with 3 LEDs on different parts of the controller, and I have the code set up here. So if I save it, it recompiles and keeps running. So I can change which LEDs are on and how, and basically real time, and see immediately what that output is. And what I've been doing is copying and pasting the output from the Watchmen into the gist thing right there. And as usual, that is my girlfriend. Oh, you wrote an article about it. What? I'm not sure which... This picture here? Oh, we really got to get back to work. I'm sorry. Okay, Micah's saying the SDK that repo includes a hardware simulator, runs emulated, binary, translated firmware. Oh, so you actually like wrote that code. Yes, at any rate, so this is all being done with LibSurvive right now. I'm going to hopefully get this working more, and then we'll have LibSurvive so it can actually read all of the lighting data from this, and hopefully in time we will be able to pass the data off to David Chapman's algorithms in order to locate the position and run the Kalman filter and all of that to figure out where exactly everything is. I'm a little bit curious if it's really necessary, especially because I'm interested in that because I noticed when I had the headset on and I could do certain things, it looks like it's using an IIR to do the correction in the headset. But I just want to see what happens if we try to use a Kalman filter instead of an IIR. At any rate, yeah, that's the goal. Get 3D tracking position data and eventually get this pokey little laptop right here, this little second gen i5, which is painfully slow, to be able to actually run Vive games. All it's got is integrated graphics. I say Vive games, I mean like Vive games that I write for it, specifically written to be fast and tiny. We really got to keep moving, though. We're going to have to get some more data here to figure out what's going on. I guess one thing I could try at this point is we could do that. And then, oh, actually, now I'm curious. What happens if... Oh, hey, guys, check that out. That bit changed. So let's do this one. I'm really going to have to figure out what's going on with transfer problem 4 with the lighthouse. I don't know what's going on there. Can you look at the Ben hint and see if we can make use of that, Brendan?
Is it way up there? It's first one to end first. It's the most recent thing I see.
From Ben. It's first one to end first. So Ben is saying it's, quote, first one to end first.
First pulse to end first, Paul has deciphered, maybe?
Oh, the least significant bit? No. First one to end first. Oh my gosh, what does that mean? Ben. Ben, why? Why is it so hard?
It says he's actually explained exactly how it works somewhere. But it's in the chat that you haven't read or something.
Actually, I just copy and pasted the wrong thing. I'm going to go back and look at chat shortly, but...
Think about how the MCU processes pulse events. When a pulse goes high, you don't know when it will end. You can't record it until it ends. So they come out in the order they end.
Oh, that's neat. I kind of figured that because, Ben, I don't know if you saw earlier, when we got it stacked up enough that there was one LED that was on for a long time while we were doing other stuff, the end of that LED came in and said that, like, yo, dog, we're done, in the next message down. So that's a neat idea, the way that you were able to make that, like, lock down to the next one. But they come out in the order they end.
To me, that says, you know, beginning to end, and then it sends the data immediately.
Well, wait a minute. Does that mean... Wait a minute. Does that mean... That could mean that the time code that we're receiving is the time code of the end. Not of... No, false. We know it's not the time code of the end because if we go back up to that packet that was on the other line, the time code started before the previous packet's time code. That was this one here. The second time code is actually less than the first, and so we know the time code in the packet corresponds to the start edge of the event, not the tailing edge of the event. I hope. It must be painful for you to watch. Just watch us squirm.
Are you reading the chat?
I can't explain LSBs in terms of his current code. He's got to fix his time decode first. Ah, Ben.
Keep reading.
No, I'm looking. Oh my gosh, this computer's too slow. Wait, no. What? What? Oh, let me read one thing here. It starts at the end. But the start's not at the end. Wait, oh my gosh, they're all positive delta. But the time code's got to be of the start event because I started the LED and then let it play, and then it came in later with an earlier start time. So like the time has got to be the beginning of all of the events, right? Right, the timestamp offset's reversed. Yes, I can. No, I can't correlate time accurately. Ugh. Ugh. When I say event, I mean transitions or on or off or anything like that. No, we are. I mean, I don't know, Ben. If you get a chance, look through the all of the copious amounts of tests we've run to try to understand what's going on. Also, I still don't know what's up with that big number in this test we got here. I wonder if it's still going to go be there. Anyway, let's keep looking. I mean, right now we have Ben here. Don't go off in the middle of nothing right now. I don't think that we're running into anything like that. I think we're a lot closer than RLE. I don't. I think that's. I would have thought that at first, but not after seeing everything we've seen. I'm still having a hard time wrapping my head around what Ben said. I kind of want some confirmation that I'm not being dumb. I mean, let's look at it. I mean, I guess maybe I just need to read it again because I am trying to like do Alt-Tab between everybody all this much. You can't report it till it ends. When a pulse goes high, you don't know when it will end. Right, so that's why we have the thing on the next lines down. Yeah, there are n minus 2 and 2 n minus 1 deltas. We did know that. Oh, that was from yesterday. So they come in the order that they end. Oh, okay, so maybe it does make sense to think about the LEDs. So I've been writing them in the order from this way, so from this way, that way. Maybe we should just be writing them that way instead. So I'm reading the... Can you guys think of a test that I could concoct where I would turn on one LED and then turn on a different LED and then turn off that LED and on a different one in order to determine if, like, which order they're actually in? If somebody can, like, write the syntax again for... So it would be... I guess we should be able to tell it... That should be simple. It should be... Can you check the chat, Brendan?
$40 or 48, 40 from Lucas.
40, 48, 40. Lucas, if you can, just type in the time chat if this is what you were wanting me to test.
It'll show on the buffer 48 first, as it ends before. 48 will, yes. Daniel Wee has a bunch of do marker 40, 40, and 40 LED 40, 80 LED 50.
Wait, who just sent that?
Daniel Wee.
Do
Sent
marker.
that to use that to check the sequence.
Oh wait, Daniel Wee. Just warning you, Daniel Wee, this is going to overlap if I do it. There's going to be no way of actually knowing. Oh, I see what you're saying. Do something like that. Okay, Daniel Wee, I just added your stuff to the Git.
George thinks there is a correlation between LED 48 and byte 7.
Byte 7.
Says that there appears to be.
I don't see it.
OXE.
He must be looking at a different data set. There will be correlations between LEDs and certain numbers, though, because the timing will be consistent among those LEDs. Does anybody have any idea what Ben could have meant when he said I needed to fix my timing code? Because I just don't know. I mean, the timing code is the same as what's up there. Okay, I'll try 40 and 48. Oh, no overlap though, so... Okay, so what's going on right here? I'm seeing 40 and 48, but I'm also seeing a massive number right there. Like, I have no idea where that came from. Like, seriously, what is up with this? Why is there 283,000 showing up right there? I mean, I guess I could just... Can you go back and start looking again?
means that the timing code isn't correlated sequentially with the LEDs.
Oh, I mean, I really could be looking at the LEDs in, or do we know if it's reverse order yet?
It's not the first timing necessarily.
Say that again?
He thinks that the first LED you read is not necessarily the first timing you read.
No, John. We want this to be all in good fun. We're trying to do something fun with hardware. That's possible. Kai, what do you recommend? Like if you guys, Kai, if you can just chat me a like using that OR notation. Don't ask the chat what is 2 to the 18. Though 2 to the 18 is just 262,144, right? I'm just pulling that out of thin air. Maybe? I certainly don't know 2 to the 19. So at any rate, CAI, if you can, make a recommendation for what code you would have checking. We're getting close to the cutoff time here. I mean, one. What does the next 10 mean? I can't set 10. George, I just don't know. I don't know what you're after. Oh, are you serious? Wait a minute. Who was the one who asked what's 2 to the 18? Is that one of the other Valve devs? Did I miss the name?
VK asked what's 2 to the 18.
VK is he one of the other Valve? Yeah, I think he was. Yeah. Oh man, no. Why did I have to poo-poo him? I'm sorry. Wait, so I still don't understand, Kai. What do you want me to test? Do you want me to do this twice quickly? Like that? Oh, that's weird. I did not... What? I don't... Why is this that output? This is crazy. What in the world? Why is...
Daniel Lee has a few more suggestions that you may not have seen. Is the fundamental time decode wrong? He also asks. That may be the problem.
I mean, I get that it's 2 to the 14. So let me go back. VK for say to VK Tuesday. There is one thing that I noted earlier on. I don't know if you were here when, but we did notice that the time codes can only represent numbers up to 65535. So the fact that it's more than 65535 means that, yes, I know that there's flags there, but I have no idea what... Oh, 2 to the 18, it's the bit 2, which is a bit that matters for us. Oh, so the 2-bit could be in the LED code, or it could be in the time code if shifted up, like time code pushed up 16 bits, I think. Yeah. That's interesting. So Ben, that line is going to live around for quite some time, when Charles did not realize the important question that was being asked. Hold on. I gotta... Ben, I would not be surprised if what you've done here compresses the data better than any normal compression algorithm that one would typically be able to use. Like, this is some very clever stuff to minimize the number of bytes that are being transferred. I do wish I was a little bit sharper right now. I'm definitely getting tired. So at any rate, the one thing that we had just discussed that VK2 says getting there, I'm guessing he was referring to me when the whole thing about 2 to the 1/8 mapping into the 2's bit of, or whatever it is. Instead of the 2's bit of the LED code. Oh, what did Kai miss?
What I thought was that maybe the time between one set of 3xDL marker and the next is too short. Also known as the display or delay between your code looping, which may cause it to try and combine 2 code loops into one packet. That was one.
Yeah, actually that's an interesting point, because if you do store a bit in like 2 to the 18, then it's only going to take, it's not actually going to take, well, okay, it will take an extra byte of data. But it's not going to be like a lot, and you don't have to store another byte telling you that it's up there. I hope a bunch of these folks are like really thinking this one through, like Paul and everyone else, because we're totally going to have to dig this one through, because my brain is pretty fried at the moment. So let's see, what conditions can we put it under, in which case the 2 will appear in there instead of in there, or the 2's bit or whatever. So if I don't do that, that's 40, 48 with the 2's bit stuffed there. And I bet you if we flip the order of those, then it'll appear in the other one. 48, 40, 48. No, it didn't. Oh, great. What does that mean? Oh, and about the whole timing thing, like which ones happens first? Well, I'll bet you if I leave this one on and set that to 40, then it'll appear in there. Yeah, it did. Okay. Why is the 2's bit set now? Oh, well, unless, but that would mean like the 2's bit means these two things have nothing to do with each other. And that it's not actually a carryover from... Okay, let's... Wait a minute. Oh, never mind. Yes! Yes! Ooh, what's going on here, guys? The do marker 1048 and 25040. So 250 corresponds to LED 40 here, even though it happens second sequentially in time. So it's like backwards from the order that you would expect it. So what in the world does that 1 bit in the there do? Why does that happen? Because, like, look, no, like, guys, this... Okay, sorry, I'm just going to copy this over there. You guys are probably all screaming at me in chat anyway, so... But that's, like, super interesting. Why is the order reversed? Okay, going up some. Bye, T. King Fritz the cat. I'm just reading what everybody's saying. I haven't gotten a chance to do that in a bit. What?
Paul commented at the bottom, and now I can't go.
You can't go, why?
Well, he was going to go, but then he started figuring stuff.
So to check the Albert thing, would that just do marker LED 80, 40, 50? I mean, we can do that, but understand that 80 or 40 and 50 are going to come on at... I'm not going to be able to tell exactly when they come on and off. Because, like, there is a slight, like, delay, but I don't know what it is. Bye, Paul. Thank you for joining. Please look at it tomorrow. Please, please, please. That would be super cool because I'm pretty sure I'm not going to be able to figure out what's going based on all of this. The basic sequence is misinterpreted. Do you mean the order that I'm reading things in or what? Because I'm pretty sure that I'm not misinterpreting it, because if I end up with extra bytes or anything like that, then I print out a warning. And so far I haven't seen any of the warnings. So that's the other thing is when the whole reverse thing. Paul, if you can just stick around for a second, I do want to show you why I think that that's not the case. So if I do LED 40, LED 50, LED 48, and LED 40, and I do 20, 30, 40, 50, and I execute that, then I get 40, 50, 48, 40, 40, 50, 48, 40. So I don't think that they're reversed. I think they're in the correct order. I know that that's not what what's his name is saying, but it doesn't. The -1 at the very end is just a placeholder I put in. It's not in the packet. The -1 is not there. It's just a thing I stuck in. Oh, William, if you want, we can work together. But to be fair, I do kind of want to work on mine. Who knows? We could just each work on our own and then just share the knowledge. At any rate, as I was saying, I'm pretty sure that the order is correct, because like 40 is first, 50 is second, 48 is third, and 40 is the last one. And they also go up, so the time here goes up. And so like in the degenerate case, it's clear that it's 40 on for 309, off for 301, 50 on for 525, off for 290, 48 on for 691, and then off for 315, and 40 on for 873. Well, on, and then it turns off because it's the end of the packet.
Did you catch the bytes right sequence wrong?
No? Bytes what?
Yeah, when you said you have the bytes right, but the sequence is wrong. Why is the -1 at the very end, for example?
Oh, no, the -1 is made up, I think I said.
Your order only comes from the first few bytes. We're talking about the rest of the data, he says.
Yeah, I do use various plotting programs when it makes sense to, but right now, I mean, like when it comes to like moving the thing around, I'm totally going to do it. But right now, we're just trying to figure out what the raw bits are.
William is going to take a look at your code. He used keyed GNU plot.
Yeah, no, I saw that.
Oh, okay.
Your sequence of numbers applies to the first few bytes, but the assignment, the timestamps might be wrong. I'm taking notes for myself so I can read these tomorrow. I don't know if Ben's still here. If he is it okay if I like actually post the text of everything he said along with the thing? All of this data is, by the way, if you guys want to like work on something and then like link in back into the chat something, that would be cool too. Like if you analyze the data and find some graph or something. I need a thing of water. I'm gonna just do a quick commercial break. Not allowed to... What, really? I can't click... What? My stream is totally live. Bummer. I just don't have access to that button. Well, you guys are going to have to just sit there without a commercial break or anything. I'm going to leave that there. I'll be back in a minute.
Progress.
What?
Progress.
What is?
For both of us. Just in general.
I still don't have an add button, though. Oh well. I don't know why that is.
I don't know if it's in front of your camera and costs like 15. That would be an ad.
That's okay. I feel really bad because I feel like I can get into the zone more when I'm the one who's working and focused on the problem. But when I'm like kind of hurting everybody, I can't really get into the zone. So I feel almost a little embarrassed that I'm so dull right now, but I guess that's just how it is. I think you guys are having more fun with it this way. And I'm having fun too, and as long as the problem gets solved, I guess I'll be happy. Night, Paul. Night, Daniel. Yeah, I don't know.
An informal ad system where we post videos in chat. Creative Commons ads from the 50s. Talk about expressive tongue.
By the way, you guys should totally... Brendan said talk about expressive. So I was going to totally do...
Two people from the comments have suggested it.
Oh, do expressive ad. Does expressive? They have like.
They have ads of any kind. Really.
No, they do. They got one. The guy made an animation. This guy. There, this thing. He totally made an ad. Look at that ad. Look at it, just all cool, and look. Whoo, expressive. Okay, back to work. Does anyone have any ideas right now? Look at the Twitter pic. Did you notification me? Wait, Alan Yates? Oh, him. How do I... I'm getting so distracted. Follow, there it is.
BK Tuesday. Oh, is that Alan? Is that?
Yeah, apparently that's Alan.
VK2Z Alan Yates. So Tuesday is not really.
Alan Yates. Wait, he sent me a picture?
He tweeted a picture. Maybe it is in your Twitter mentions?
I don't see a picture though. Oh!
Yes, you do.
Oh, now I see it. Oh, why? Oh my gosh. Okay. These puzzles are getting so ridiculous. 0, 2, 3, 4, 1, 5. Oh, well, you know what? Let's see what that looks like. I'm going to save this picture. Oh my gosh. Okay, I can't wait to see what that output turns into. Kamal. Oh yeah, hey. Hi Kamal, thank you for using. This is all good. Okay. Time for us to go see what that picture actually does for us. So I'm going to take that picture and I'm going to go put it into code. And so it's going to be LED, let's make all these 20 to make that simple. LED 40, LED 50, or 40, LED 50, boom, there. Then LED 50 or LED 48. And then LED 50, and then nothing. So that's first transition up, second transition up, first transition down, second transition up, second transition down, last transition down. Okay, so this code should be Are you guys seeing this? Because I'm really confused now. 41, transition 1, 48, nothing. Transition 1, 53. So 53, is it going 1? Oh. So the 1 means it's associated with the first. Then 48. 48's only on for a little bit, and it does not associate with any other events. But then why 53?
Making all your timings identical is making your life so much harder, system. In all caps.
No, I want to figure it out here, because I think the 53, the 1 means it's 1, the event is 1 away from where I am, and then the 3 would mean that it's 1, 2, 3 away. That's 1 event back, 2 event back, 3 event back, and it's an implicit 1, so it's the amount that it changes. So well, let me at least copy this into the text file and then Okay, you're right, Ben. That does make it a little bit easier because you can clearly see like 867 and the 151, and that's such a good test, but I don't have enough brain cells still firing to figure out exactly how to decode that. But so the 41 means it's 40, and then the ones bit means that it applies forward some amount. And then 151. Oh, neat. So it's 40, then 151 later, 552 happens. No, that'd be 20, so... Where in the world... Why the 552 there, though? Oh, 48. Okay, so that's on, but then the 1.
Give each delta a different prime number for testing, says Micah with a smile.
Yes, we're getting there.
Every time you groan like that, Bistromat's dog looks around and groans back.
Somebody just read me the thing about every time I groan, Bistromat's dog groans. By the way, you guys do kind of have a bad voice synthesizer playing back everything, because inverse phase is here reading back things that matter. Okay, fine. Although, you know what I really should be doing right now is I should be making it so that the numbers round to approximate like numerical values that match up with these. So I think that would be better use of my time. Let me go speed this up some, and then it'll line up better. Okay, so what I did here, just so you guys can see, is I modified the oscillator clock on the AVR so that the length of each one of these is approximately 10 times the total number 48 millionths of a second that these are representing. So 1, 2, 5, 8, wait, not 8, 1, 2, 5, 7, 11, is that the next prime, I guess? Okay, what? Why? Why is there a? Why did the 2's bit just turn on and 2 the 18 thing? Ah. What? What is that doing there? Hold on, let's go back to. Okay. Oh, I'm not even gonna bother with that. Cabbage? I've never seen that one.
I just made it up.
Okay. Back to work. How's it going?
That well?
Adam Geary just got back and asked how it's going, and I'm sighing heavily.
I see I've taught you well.
Moni 0147.
Okay, I have no idea why there's a 2, like, sorry, a 1, 2 to the 18. What is that doing there? Why did it switch from 41, 48, 53 to the codes with that? Maybe it's just different ways in which they can index the... Oh my gosh. I do appreciate that you're trying to reverse engineer it. I mean, you never know if Ben is not feeling particularly charitable, and we can't get it, then we might have to resort to it. Although I don't want Ben to tell us if he plans to tell us eventually if we don't get it. Okay. That's so weird. 53. The following is in reference to Alan Yates' picture on Twitter. Ben, I do want to ask, just for the sake of having this as a big thing that we can all go back to, do I have permission to post the text file that you provided, or not you provided, but these tidbits of conversation in the gist that I'm going to be having? Because I don't know, I think it'd be nice to remember all of this. Oh, wait a minute, Ben. Are you telling me that you did the compression in the FPGA? Because that's insane. I'm okay with using FPGAs as glorified shift registers and capture compare, but really? Okay. What? Oh, that Ben, that makes it sense with the why it would be reverse engineerable so quickly, because when I plug it in to the USB, it gives it in the simple format, whereas when I have it on air, it gives it into the ludicrously complicated format. Can I ask you guys something right now? And I hope that you'll tell me this. Is everything we're doing right now all going to be for naught because you're going to drop some firmware update in that's going to completely lock us out? Because that statement there scares me. Oh, unless I'm decoding that number incorrectly. Yeah, that doesn't line up to anything. Yeah, I would have to be decoding that number incorrectly.
Excuse me.
No, 0F49F4. So I am decoding that according to the rules. It's very strange though that that doesn't line up to anything. Well, we're not going to try to lock you out. But we're going to add features someday that will break this without caring that it will break you. Oh, I'm so glad you guys care. The good news is I only need this to work for my project for a little while, because in 3 months I'm going to have moved on and I'll have been working on a different thing then. Everybody else who wants to use this, though, they're going to be very sad. But I don't need to do my own wireless protocol. I have my own. I'm going to be using unassociated 802.11 packets for what I want. The same as I've been doing on like the 3D localization video and a bunch of other things. Being able to use some of the much faster sampling rates. Oh, different hardware. Okay, yeah, sure, I get that. Fine. You're going to change that because of the different hardware. I am A-okay with that. If somebody else wants to use their Vive with my system, they're going to have to go do this reverse engineering thing themselves. I don't really want to go too much into what my particular project is for the Vive, but it's a whole lot of steps to get somewhere that's not actually that cool. But I think it's going to be much more the adventure in trying to get where I want to be. We really need to figure this out, guys. Like this thing here, what is up with these bytes? Why is this particular field so high? Like, what is going on there? Like, I just checked, and yeah, I'm actually decoding that right. I think. I mean, I guess I could put it into calc and we'll see. Yeah, I'm decoding it according to the rules correctly, it looks like. Yeah, I really like that idea of having the extra... I love the idea of not saying how many parameters there are, but knowing how many there are based off of the fields. That's pretty cool. Anyway, guys, do we have any idea why it would change the encoding when I move from 70 microseconds to 80, or not microseconds, 80 time units? I just realized something dumb. I think I'm sending this thing out at 4 megahertz. Not 1.8. Oh, whatever. No, it can't be 4 megahertz because the AVR is running too slow. I mean, the number is right here. But the problem is that the number is a whole bunch of things all kind of stacked together. And there's like no good split at the 16s mark or anything like that. Like if I do minus 262144, as what's his name suggests. Oh my gosh, it's a negative number! Why did I not think to try that? Oh my gosh. Okay, let's do that now. Let's add that to the code. Found something new. So you can have negative time deltas. Oh, that is weird. Although that number doesn't make any sense. That number is way too big. Why is that number so big? That can't be the right number, because that would be too big. That would be boop. 1 plus 2 plus 3 or 10 plus 20 plus 30 plus 50 plus 80 divided by no, it's not 10. That's times 10. Yeah, that's way too big. Okay, never mind. So what is the significance of it being negative? My delay between batches is a very long time. Ben, how is it? Oh my gosh. No, it's not negative. Okay, well, so like, look, if I don't do a negative here, this number right here, like when I look at it, I have ones and zeros like pretty evenly strewn all throughout the number. The only thing I can really think of is maybe it's like, I mean, I don't even know. Like, that's just a complete mess of ones and zeros. There's no... Not to look here, but I don't get it. Otherwise, it's a mess of ones and zeros. I'll look up what the delay between the two packets is. It's 10 milliseconds between packets. I already did figure out it. If you Trip, if you want, go look at the gist. I have at the bottom of the gist one packet where it doesn't update and one packet where it does trigger.
Did you catch the time deltas are all positive from Jeremy?
Say it again?
Jeremy said time deltas are all positive. Just in case you didn't see that.
I did see that. But I still don't understand how it could be a positive number unless it's like the actual time shifted over by some amount. Oh, that's why he wants to use the exact number. For all of the following, we will be used. Trip, do you want to know more precisely? The time decoder I'm using is somewhere here. The time decoder I'm using is called Arcane Pop, in honor of Ben calling this type of compression arcane compression. It's in survive_data.c. Oh yeah, Ben, whenever you get back, or if Ben is back now already, it was 10 milliseconds between packets. Yeah, it's not normal, but I don't think it matters, does it? I mean, I guess we can test that. We'll test it. How about that? So now it's 2.6 some big number, I don't even know. Let's go increase it to 11 milliseconds. Oh, it is. Why does that matter? Why does that number change based on the scan line difference? What do you know that I don't, Trip? What do you know that I don't? Why? Why is that a thing? Why? No! No, you wouldn't have done that. I don't even want to say it out loud, because there's no way. Oh, yeah, you know, you're right. It probably isn't 11 milliseconds. Why, though? Why? No, it's expected output now that I'm getting a little bit of a... Yeah, the AVR clock is totally... It's not milliseconds. I don't really know what it is. I didn't even bother thinking about it. But as he pointed out, we can calculate it now. It would be... he says 280,000. Actually, it would be better for me to use the other number since it rounds to 10 nicely. What did he recommend? Oh yeah, 4086. Why is the AVR clocked higher? I thought the AVR was clocked lower. Yep. Oh well, I guess the AVR is clocked higher. It is actually operating at like that other frequency, the 4 point something megahertz instead of the 1.8. I don't know why. Whatever. Maybe I enabled the PLL? No. Yeah, I never enabled the PLL. It shouldn't be that high. That's totally wrong though, so whatever. I'm just going to comment that out. Delete it. Okay, so... Wait, 5.3, you mean 5.8 milliseconds, right? Oh, that's per 10. So if we want to divide that by...
Did you see what Ben said? You're sending a sequence A, B, A, B, A, B, A, B, and seeing EA, EA, EA come out. It's not a bug. Ben is enjoying how the controller is acting as a logic analyzer for finding bugs in the reverse engineering code.
Edwin called it. That is true. I really wish you guys, all the people who are watching right now, had one of these to play around at home with.
I'm guessing many of them do, but not all.
Which, by the way, if you guys have Vives and you're not doing this right now,
You should if you are.
I just set it to like the 16 millisecond time. Why is this? Shouldn't it just be giving up eventually? Wow. 16.4. Okay, fine. I'll go a little bit longer. 32. What? What is the point in having something only that... Why? Why? That's 17 milliseconds. Why are you still holding on to the data? Like... Why?
George is adding macOS support to LibSurvive, I guess.
George, are you adding it to Live Vive or Live Survive?
He said Survive.
Okay, that's cool. Thank you. George, if you have OS X, specifically David Chapman, the guy who's doing the other work on this, has a lot of interest in doing OpenGL Windows in C. And so, like, he has a solution right now, but I'm trying to think of a good way. If you can send me a personal message with your email so I can hook you up with David Chapman, I think that would work out really good because he's a dev who likes using OS X.
BK2say says check the delta decoding around line 57. It isn't correct. Ben says your debug data is so different from real data that you're seeing strangeness, but the thing you're decoding is still accurate.
Line 57.
357. Delta decoding.
Oh. I didn't even think to look at that. I'm pretty much too tired now, though, to make any changes that would be significant. Now, I know your coding is representing reality because, like, it's a linear transform and somehow the AVR is just clocked that high. Like, I get it. There is a famous quote, which is 99.9% of all AVR UART problems are actually clocking problems. Kai, the other thing is once I can handle the data from this, I'm totally going to just go fire up the lighthouses and see if I get data that's reasonable back, because I do have the main headset dealing with the data in that way. Make-J would probably explode my shell. Why would it explode my shell?
I think they're talking about someone else's show.
Oh, okay.
Maybe.
I don't even know what to check anymore. I don't even know what to change. Like, at this point, I'm so lost. It's just going to take thinking and looking at numbers. And it's already 12:12, which is getting really close to my stop time. Oh, haha, you were going to have somebody copy and paste the \make-J. Yeah, that would explode. Do I have anything written here that would be a bad command, though? No, I don't see anything. So you say line 357. Man, I wish I had thought about this earlier. We could have had like an official recorder or somebody who was actually like tasked with like taking notes. Trying to remember, what was the thing? Somebody said got it. Where is it? Oh, there it is. VK2Z, which I've already forgotten his actual name. I don't know how I've forgotten because I still have it up on Twitter. Alan Yates. Alan Yates. Oh my gosh, if I can get people playing with Live Survive, I would love to have some extra eyes on that to really get that fleshed out so I don't have to deal with all of the stupid bugs in it myself. I really don't even know what to change to... Oh, that's right, this thing. Parameters, power place to delta A. No, I know it's wrong now, but I'm still trying to figure out what the correct thing is. So, like, this here... Oh, actually, you know what I can do? We can use the prime thing again.
Max can now connect to the controller using USB.
Well, whatever that limit is, we've just now found out we can flirt with it. I don't know if you guys care. I think it's just a little weird that it's fluttering. Maybe I'll just copy that just in case. You're having problems with Watchmen command codes? Oh, no, I have a day job. I just spend a great deal of time making my projects and working on making YouTube videos. And I assure you, nobody could be a professional YouTuber at 20K subs. It would take it would easily take 500,000 subs before you could really make it a professional job. Unknown Watchmen code 32. Oh, that's really weird. To do. I'm gonna have to close up the stream soon, but look at these values and try to figure out what's wrong with the delta A, delta B code in survive data.c. Let's see, does anybody have any further notes that yeah, I do have a Patreon. If you guys do want to straight up do it, the Patreon's more for individual projects though, so something like this would not fit into the Patreon. So let's just say we're gonna stop like actual deving for tonight. I've taken all the data I'm gonna take. I'm going to commit what I have here. Okay. Any other notes that... Yeah, I know it looks like two fields mashed together, but we are pretty sure that it is the amount of time between the two frames. So no, actually that was covered a little bit earlier, Ryan. The numbers that are there are reflecting reality. In that regard, I'm pretty sure that's what they had indicated. And when I changed the delay between the packets or whatever, it went up significantly. So it really is that like 17 milliseconds or whatever between sending the messages. I hope I've gotten at least a couple other people interested. Maybe maybe some of you guys are going to go download LibSurvive on Linux or OS X. And George, make sure to commit, do a push back to my repo for the OS X support. I hope some of you guys are going to get like inspired to actually start trying to use this LibSurvive stuff. And once this is solved, I'll start doing more development on the side that I need to in order to get to the project I've been trying to get to. Anything else before we go? Anything that you guys can think of that you really want to see, like some combination of lights on and off or anything like that? I really don't want to get into the final goal. It is it is really lofty, and I don't really want to sign up for something I don't think I'm going to be able to succeed in. Yeah. If for some sort of specific reason having to do with I'd be willing to talk it over with specifically the Valve devs offline about what I'm trying to do, but I don't want my goal to. Yeah, I don't really want to dig into that. Live Survive, as of right now, won't work on Windows that I'm aware of. I have used Live USB in the past, but it would take. You would have to install the device filter so that you could talk to all the Vive pieces of hardware, which would probably mess up the drivers for use with the Valve stuff. And so it would be a complete pain. You'd have to keep going back and forth and back and forth and back and forth, disabling all the drivers and re-enabling them so that you can use your Vive with Steam instead of Live Survive. Direct message on. Hold on.
Probably Twitter.
You can direct message people on Twitter?
Yes.
I didn't know that.
You go to their page and click message.
Oh my gosh. Type